Good morning, students. Yesterday in the last class we have studied about discrete Fourier transform. Today we are going to see inverse discrete Fourier transform. So in this discrete Fourier transform we have converted the time domain signal into the frequency domain signal. So in discrete Fourier transform we have taken the standard formula, that is x of k is equal to summation of n equal to 0 to n minus 1 x of n e to the power of minus j 2 pi by n kn. So that was the formula for DFT. So now we have solved some problems. Three type of problems we have seen, that is by using one function, another by using the sequence, that is the values will be given and you are going to substitute the values based on the value of capital N. So number of samples. So based on those things we are going to see now we are going to see the inverse discrete Fourier transform. So in inverse discrete Fourier transform we are going to convert your frequency domain into the time domain. So the standard formula is given as x of n equal to 1 by n summation of k equal to 0 to n minus 1 x of k e to the power of j 2 pi by n kn. So here n, where n is the number of samples, capital N is the number of samples and small n is the number of input signals, that is and x of k is the sampled signal and x of n is the input signal. So here in discrete Fourier transform you are going to convert your sampled signal into the original signal x of n. So we have seen in the last class how to find out the IDFT of a sequence. So based on the data given, if 4 inputs are given then n value is 4. So take the IDFT formula, x of n equal to 1 by n summation of k equal to 0 to n minus 1 capital X of k e to the power of j 2 pi by n kn. So whenever the n value is taken as 4, the value of k will range from 0 to 3, that is n minus 1, capital N minus 1. So x of k e to the power of j 2 pi by n kn. So the n value what we is given is 4. So here the summation formula you are going to expand by taking k equal to 0 to 3. First k equal to 0, if you substitute, the first value will become x of 0 and e to the power of 0 will become 1. So that's why directly we have written x of k plus k value equal to 1, therefore x of 1 e to the power of j 2 pi by n into k. K is 1. So e to the power of j pi by 2 n plus x of 2 e to the power of j 2 pi by n into k value you are taking as 2 into n. So like that you are going to substitute the values of k as 0 to 3 and then you are getting the value of x of n. So x of n value, once you get this formula, then you are going to substitute the value for n equal to 0 to capital N minus 1. So first for n equal to 0 you will get x of 0. Similarly whatever you have done in DFT, same thing you are doing in IDFT. The formula whatever you have got for x of n, you are going to substitute the values of n equal to 0 to 3 and get the values of x of 0, x of 1, x of 2, x of 3, 4 values we are going to get, and that is the sequence what we obtain for IDFT. So coming for another problem for IDFT, solving the IDFT problem. So in this again we have got the 4 values, so we can take capital N equal to 4. IDFT formula you are going to substitute, take the standard IDFT formula, x of n equal to 1 by n summation of k equal to 0 to capital N minus 1 x of k e to the power of j 2 pi by n kn. And now you are going to substitute the value of k as 0 to n minus 1. In the formula you are going to substitute the value of k equal to 0, 1, 2, 3. You get the formula in this manner. Then you substitute the value of n equal to 0 to 3 and get the value of x of 0, x of 1, x of 2, x of 3. So once you get these values, then the sequence obtained is IDFT values. And you can try these, copy down these problems from the PDF sent to you, and try to solve the problem of this one, that is x of k, and then we will discuss the further things in the next class.